So cis-trans isomerism, it is otherwise called a geometric isomerism. That is, two same groups on same side means it is called as cis. Two same groups on opposite side means it is called as trans. So here in this case, you should have a double bond first. You should have a double bond first. That is, the enes will have this type of isomerism. So the compound A and D cannot be the structure. That is, that will not exhibit cis-trans isomerism. When you go for B, see here, it is only, that is, the valency of the carbon is not satisfied. So B cannot be the structure. The answer is D for this. I'll tell you, sorry, answer is C for this. Here, that is, you have C, single bond C, and you have one hydrogen Cl. The same way for this hydrogen, one Cl and the hydrogen. This is cis. And when you come, that is, this is the double bond. And when you come for the trans one, C double bond C, Cl, H, and this side, this is hydrogen, and this is Cl. So this is trans. So the compound which exhibits this trans isomerism is C. The next, which of the following possesses sp carbon in its structure? So sp carbon means you should have either triple bond, and that is, you should have two pi bonds in a particular carbon. That will have sp hybridization. So when you go for the structure A, one pi bond is there and two hydrogen. It is triangular, so it is sp2 hybridization. The second carbon is also sp2, third carbon sp2, and in the fourth carbon is also sp2 in option A. And when you go for B, again, it is sp2. Both the carbons are sp2. When you come for C, the first carbon is sp2, but the second carbon, when you look at it, you have two pi bonds and the structure is linear. So that the center carbon in option C is having sp structure, and the third carbon again sp2. When you come for D structure, the CH2, it is sp2, and the next CH, that is also sp2, third CH sp2, and the fourth is also Fc2. So the answer for this is, that is, CH2 double bond C double bond CH2, and this center carbon is having sp hybridization. So the answer is C for this.
Ma'am, triple bond represents sp hybridization, no ma'am?
Yes, ma, but that is, triple bond is nothing but one sigma bond and two pi bonds. Sorry, that is, when you go for acetylene, 1 minute. When you go for acetylene, it is CH triple bond CH, right?
Yes, ma'am.
Here you have two sigma bonds and two pi bonds in each carbon. Am I right?
Yes, ma'am.
The same thing is happening in the C structure in the center carbon. Two sigma bonds are there in both the sides and two pi bonds are there. The structure is linear. Instead of three, that is, triple bonds in one side, we are having double side. Two sigma bonds and two pi bonds are there. So that is linear. Okay?
Okay,
Yeah.
ma'am.
Is the next one. Cyclic hydrocarbon A has all the carbon and hydrogen atoms in a single plane. So listen carefully. A cyclic hydrocarbon A has the carbon and hydrogen atom in a single plane. All the carbon-carbon bonds have the same length which is less than 1.54 Armstrong but greater than 1.34 Armstrong. See this, this you have to have in mind. It is a cyclic hydrocarbon, so closed ring structure, and the single bond length is 1.54 and the double bond length is 1.34. So if it is having the length in between these two, that carbons will have partial double bond and partial single bond character. So there should be alternate single bond and double bond. It is nothing but the benzene ring. A cyclic hydrocarbon is the aromatic ring.
Yes, ma'am.
Yeah, benzene ring with alternate double bonds. So all are having same bonds, and the bond length is that is one between
120.
1.54 to 1.34. So what will be the angle here? So this
120.
yeah, 120 degrees. So the answer is D for this. Yes. The next, the Laziness test is used in qualitative analysis to detect nitrogen, sulfur, chlorine, all of this. What is the answer? So in the Laziness test, we can test nitrogen, sulfur, phosphorus as well as halogens. All these. So the answer
All
for
of these,
this,
ma'am.
yes, the answer for this is D. The next, which of the following statement is not correct? See the question again. Which of the following statement is not correct? So you have to choose the wrong answer. The double bond is shorter than the single bond. Of course, the double bond is shorter than the single bond. Next, sigma bond is weaker than the pi bond. That is not correct. Sigma bond is very strong because there is a direct overlap between the atoms. So sigma bonds are stronger than the pi bond because pi bonds are formed by which overlap? By direct overlap sigma bond. Pi bond by sideways overlap. By sideways overlap. And the double bond is stronger than the sigma bond. Yes, covalent bonds are stronger than the hydrogen bond. So the answer is B for this. When the hybrid state of carbon atoms changes from sp3 to sp2 and finally to sp, the angle between the hybridized orbitals. So what is the angle for sp3? Yes, bond angle for sp3. Hello, it is 109.5, and for sp2 it is 120,
120.
and for sp it is
180.
180. So what happens to the bond angle from sp3 to sp? It is increasing,
Increase
right? Yeah.
progressively.
So the answer is D for this. It is increasing progressively. So, which of the following fertilizer has highest nitrogen percentage? Yes, yes. Which of the following fertilizer which contains highest nitrogen percentage? Yes, any idea? It is urea. The percentage of nitrogen is high in urea. Generally, that is the urea is the fertilizer which is used for getting more percentage in the soil for the growth, greeny growth of any plant. Urea is needed, which contains lot of nitrogen. Yes. The restricted rotation about carbon-carbon double bond into butene is due to, so 2-butene structure is CH2 double bond, CH single bond, sorry, 2-butene, sorry. So this is the bond.
Single bond
That
only.
is, that is not the, that is CH3 single bond, CH double bond, CH, sorry, CH3. So this is 2-butene, and here the restricted rotation is happening because of the double bond, that is CC double bond between 2 and third carbon. And here this happens, overlap of 1s and sp hybrid orbitals are here. It is not happening there like that, and overlap of two sp2 hybrid orbitals, and overlap of 1p and sp2 hybridized orbitals, sideways overlap of 2p orbitals. Which will be the answer? Already we have sp2 hybridization for carbon, and that sp2 with s is ch bond, and CC bond, single bond, is due to two sp2 hybrid orbitals. The answer is the sideways overlap. D. The answer is D for this. This is due to sideways overlap. Is the
Ma'am, please
next?
explain that again, ma'am.
I couldn't hear you, ma.
Explain that again, ma'am. I couldn't
Yes,
understand.
ma. See here, that is the first carbon is sp3 hybridized, second carbon is sp2. The double bond carbon, two carbons are sp2 hybridized, isn't it?
Yes, ma'am.
So that sp2 hybridization, the first option when you go, the overlap of one s orbital and sp2 hybrid orbitals happens for the ch bond. This carbon, second carbon, and the hydrogen that is attached is the first overlap, and overlapping of two sp2 orbitals happens, that is for cc single bond, cc single bond, and you have one unhybridized p orbital, and because of the pi bond only there is restricted rotation. How the pi bonds are formed? The pi bonds are formed by sideways overlap.
Sideway overlap, ma'am.
That is the answer. And the restriction
Okay,
rotation
ma'am.
is due to the presence of pi bond, and the pi bond is happening because of sideways overlap. Is it clear?
Yes, ma'am.
Yeah. Yes, the next is the most reactive compound for electrophilic nitration is electrophilic nitration means the attacking group is NO2 plus. So NO2 plus is the attacking reagent. So in which compound, that is the options that are given are benzene, nitrobenzene, benzoic acid, toluene. So among these compounds, which will readily react with NO2?
Nitrobenzene.
What is the nature of nitro group? So when you draw the resonating structures for this, NO2 is electron withdrawing group, right? So NO2 group that is attached to benzene ring, what happens? That pulls the electron to out of the ring. The same way benzoic acid is also electron withdrawing group. So what these two do means, these two pull the electrons out of the ring. But in the case of toluene, the methyl group is attached, which is electron donating groups. No, toluene, that is the methyl group is electron donating. So what happens here means that toluene, the methyl group, since it donates the electron to the benzene ring, the benzene ring becomes electron rich. அப்போ எங்க electron rich இருக்கோ, in that place only the electrophilic attack will happen. Okay.
Yes, ma'am.
So the reaction happens more easily. That is the most reactive one is toluene. The next is benzene. Third one is benzoic acid. If they ask for order also, you can write it. First is toluene. The next is benzene. Third one is benzoic acid. And the fourth one is nitrobenzene. This is the order. Next, which one of the following order of acid strength is correct? So first is RCOH, carboxylic acid, alcohol is there, water is there, and acetylene is there. Acid, alcohol, water, and acetylene. So the order is so acid strength. One minute. Ma கேக்குதா நான் பேசுறது?
Yes, ma'am.
Yeah. இப்போ கொஞ்ச நேரத்துக்கு முன்னாடி கேட்கலையா ஜெயஸ்ரீ?
Yes, ma'am. கேட்கலைங்க ma'am.
I got a call, அதனால கட் ஆயிருக்கும்னு நினைக்கிறேன். Okay. Yes. So here the acid group, that is acid is a substance which gives out H plus very easily. Am I right?
Yes, ma'am.
That is an acid. So we know that COH group is a strong acidic. So the first one is ACOH. What will be the next one? What will be the next one?
Alcohol group, ma'am.
Is it so? Alcohol are now only in the question that we have studied the before one. R is the electron donating nature. So that will not gives the H plus very easily. That holds the H plus. ஏன்னா ஆர்லேருந்து என்ன ஆகும்னா electron is donated to oxygen, so the oxygen will be electron rich. அப்ப என்ன பண்ணாது H plus அவ்வளோ ஈஸியா வெளியில போக விடாது. that holds the electron, sorry, that holds sixth one is acetylene. In acetylene, the S character, this I told you when I took the class. Acetylene, the percentage of S character is 50. So when you go in the that is percentage order, There is acetylene is having 50 percentage of S character. They'll be asking question like this, which is more acidic also? Acetylene, ethylene. In case of ethylene, that is double bonded compound, the percentage of S character is 33.3, because that is how to find out the S character means. In the case of triple bonded compound, um, what you have is that is the hybridization is sp. So one s and one p orbital they combine, so totally 100 percentage. That divided by 2, it is 50 percentage S character. But in the case of what to say, in the case of double bonded compounds, 1s and 2p orbital they mix together, so 100, so totally 3, so 100 divided by 3, it is 33.3. And in the case of single bond, it is sp3 hybridization, so 1s and 3p, so the percentage of S character is 100 divided by 4, it is 25. Okay, so in the case of acetylene, it is 50 percentage. Next will be water, and then only you have the alcohol. So here the option is D. The option is D for this. Is the next one. This you have to work it out. The percentage of carbon, hydrogen, and nitrogen in an organic compound of 40, 13.3, and 46.7 respectively. Then the empirical formula is how to do this. Tell me how to do the steps alone. I'll give you the answer, you just verify. Yes? Any idea? Hello? First, what you have to
Ma'am,
do is uh, the
percentage
percentage.
atomic mass.
Yes, you have to divide by atomic mass. So it'll be first dividing 40 divided by, that is, this is carbon, so it is 12, and 13.3 divided by 1, and for nitrogen it is 46.7 divided by 14.
Okay,
So
ma'am.
here it is a approximately that is 3 point something will be getting. Here it is 13.3, and here also you'll be having, that
3.3.
is again 3, in the range of 3 you'll be getting. So next you have to divide by the lowest number, right? Divide by
Yes,
the
ma'am.
lowest number. So for carbon and nitrogen it will be 1, and when you divide 13.3 by 3, it will be 4. 4 threes are 12. So 1 carbon, 1 nitrogen, and 4 hydrogens are present. So the answer will be
A, ma'am.
1 carbon, 1 nitrogen, and 4 hydrogen. அம்மா இதுக்கப்புறம் என்ன பண்ணணும் அப்படின்னு கேட்டிங்கன்னா, you have to divide by the lowest value. So 3, when you divide the first and 3, that is the carbon and the nitrogen, by 3, you'll be getting 1, right?
Yes, ma'am.
Yeah, 13.3 divided by 3, you'll be getting 4.
Okay, ma'am.
4 threes are 12. So the answer will be C, not A.
Okay,
Sorry,
ma'am.
not A. The answer is C. Yeah, this is the answer. Is it clear, ma?
Clear, ma'am.
Purida, shall I repeat it?
Clear,
Puri,
ma'am.
Puridilla? Okay, I'll go for the next one then. Is the IUPAC name of the following? Is See here, in the last carbon, you'll be having a triple bond. There, you'll be having one more bond. This is the compound. So, what is the name of this compound? Which should be given preference? And preference either kudukuromo, the name should be at the
Triple
end
bond.
like that. Yes. How the numbering should be from left to right or right to left?
Right to left, ma'am.
So எந்த பேர்ல முடிக்கிறோமோ that should be given lowest number. Am I right?
Yes,
So
ma'am.
when in the priority order, first comes the double bond and then comes the triple bond. That is the priority order. So double bond is the preference, right? So that should end with ene. ன்னு முடிக்கணும். The name should end with ene. ene or yne?
For double bond E and E, ma'am.
ene. So you should end with ene. So how the numbering should be, right to left or left to right?
Left to right, ma'am.
Are you sure? So which will be the answers here? The option is not there like that. See, it is numbering should be right to left, but you should end with ene. So the answer here is 6 carbons are there, so it is hexene. But yne is at one position. So hex 1 ine 5 ene. So that is C. Here the one number is missing. That is hex 1 ine 5 ene is the answer. So what is the definition for geometrical isomers? Geometrical isomers differ in position of the functional group. If the position of the functional group differ means, what is the isomer called? What's the name of the isomer if the functional group position differs means? It is position isomerism. If the position of the atoms differ means it is tautomerism. If the length of the carbon differs means it is chain isomerism. So the spatial arrangement differs means it is the geometrical isomerism. The answer is the spatial arrangement. Yes. Which of the following is incorrect? Which of the following is incorrect? Option A, ferric chloride is used in detection of phenol. Felling solution is used in the detection of glucose. Tollens reagent is used in the detection of unsaturation. And sodium bisulfite, sodium hydrogen sulfide is used in the detection of carbonyl compounds. This lesson it is not coming. That is in the first lesson it is not coming, but you'll be studying in the later lessons. The first one, The test for phenols it is. With a neutral ferric chloride, the phenols give violet coloration, blue or violet coloration. That is the test for phenol. So ferric chloride is used for the detection of phenol. That is the correct one. And the second one, Fehling solution is used in the detection of glucose. That is also right, because glucose, the reducing sugar, when you add Fehling solution, what is the Fehling solution? You have Fehling A and Fehling B solution. What are they? Please note it down. Fehling A solution is sodium potassium tartrate. Fehling A solution is sodium potassium tartrate. And Fehling B solution is dilute copper sulfate. Fehling B solution is dilute copper sulfate. So if to the glucose solution, if few drops of Fehling A and Fehling B is added and heated, means you get brick red color of copper oxide. uh, that is cuprous oxide is formed. Cu2O is formed, which is brick red color, and that red color shows the presence of reducing sugars like glucose. And next one is tolerance reagent. The what is the tolerance reagent means? It is ammoniacal silver nitrate solution. Tolerance reagent is ammoniacal silver nitrate solution, and generally this tolerance reagent is used again for testing the carbohydrates. And this is one of the very important tests to differentiate aldehydes and ketones. This is the test which is answered only by the aldehydes, not by the ketones. This is the only test. And we have one more test, that is sodium nitroprusside test to differentiate aldehyde and ketones. And this is the very easy test to differentiate aldehydes and ketones. And this is not used for the detection of unsaturation. For unsaturation, we'll be adding bromine water or KMNO4 solution to find out the whether your compound is saturated or unsaturated. So the tolerance reagent, it is used for the detection of glucose to differentiate aldehydes and ketones, not for unsaturation. And the next one is sodium bisulfite, and this is used for detection of carbonyl compounds. That is correct. So here the question that is asked is, which of the following is incorrect? So the answer is the tolerance reagent for the detection of unsaturation. Tolerance reagent is used for the detection of aldehydes and ketones, as well as the carbohydrates that is present in the given compound. Is it clear? Ma Jayashree?
Yes, ma'am. Fehling B
I
solution is
think,
what, ma'am?
yes, 1 minute, ma. I couldn't
Fehling
hear.
B. Fehling B, ma'am.
Fehling B is dilute copper sulfate solution. Fehling A is sodium potassium tartrate, and Fehling B is dilute copper sulfate solution. And
Okay, ma'am.
tolerance reagent is ammoniacal silver nitrate solution. Okay?
Yes, ma'am.
Yeah. Okay. So let's see. If you have any doubt in this lesson, also you just post me, ma. Uh, I'm working out the answers for your questions. What you have that is sent me. Along with that,
Okay,
that
okay.
send you the reminder. That is, if you have any doubt in this lesson, also I'll work it out, and either I'll post you or I'll explain you in the class.